Hello, and welcome to today's webcast, Veritas NetBackup, Best Practices for Improving Performance, brought to you by Datalink. My name is Danielle Moore, Marketing Manager at Datalink, and I will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webcast is designed to be interactive between you and the presenters. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. All questions from this webcast will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn over this presentation to our presenter, Chet Boardman. Chet, the floor is yours.
Thank you, Danielle. Welcome, everyone. Thank you for taking time out of your day to spend some time with us and hopefully learn a few tips or find some interesting items from this presentation. I'm going to go ahead and get us started. Today we're going to cover NetBackup best practices, and we're going to include some tips, techniques, and configuration items that will help improve your NetBackup performance, as well as it will allow your environment to be more stable. So we'll start off with an overview. And here we'll just cover the table of contents of what we're going to do. We're going to cover the NetBackup overview. We're just going to give a brief view of NetBackup and some of the basics that go with it. We'll dive into some of the NetBackup best practices for configuring your environment, performance tuning, and whatnot. We'll dig into under the hood look at deduplication technology, how it works, and factors that can impact deduplication performance, job throughputs, as well as deduplication rates. We'll cover the types of data that affect deduplication. We'll move on to best practices for NetBackup and SLPs, how to use your SLPs to make them more efficient. We'll discuss stream counts and networks and how to calibrate your stream count to match what your network throughput is going to be. We'll discuss AIR and some of the features included with AIR. We'll cover some of the best practices for SLP implementation, and we'll finish up with some final thoughts and questions and answers. So let's start off with the basic part of NetBackup and just covering our overview. So NetBackup isn't one application. The majority of the way NetBackup is, most people think it's one application. It's actually three components that make up your application. So you have your master server, and this is the brains of the operation. It handles your scheduling, it manages your catalog, handles your restores, as far as scheduling and gathering resources. So this is the main component. This is kind of the head of the operation. And so it's kind of the critical component of NetBackup. Then you have your media server role. Now this is the role that is handling your data movement. So it takes in data and puts it out to storage, whether it's tape, disk, or deduplication storage, either MSDP or third-party deduplicated storage. The media server is going to handle the work. It's going to take in that data and write it out. It's going to read the data from storage and put it out toward the client for restores. And then the third component is the client, and this is where your data is being gathered. The NetBackup agent will gather the data, feed it over to the media server, which will write it out, and then it will update the master server. So these three work together to form the NetBackup environment, also known as the NetBackup domain. And this overview is going to kind of be, we'll discuss this further in the presentation. There'll be items specific to each component here. So best practices, we'll start off with the master server. So the master server, since this is the brains of the operation, it handles your scheduling, your resource allocation, and all the components of NetBackup, there's some considerations with this that in best practice you'll want to follow. So the master server should be a dedicated resource. You should have a master server that's all it's doing. Being a master server, it's not your Oracle server or Exchange server. Ideally, you want this to be its own server so that it can be dedicated to handling your job scheduling. It's not strained for resources, and it can handle everything without struggling. So that's one of the critical things. The second critical thing, do not play with the NetBackup files outside of the NetBackup command or console without being fully aware of the impact of what's being done. And what's meant by this is going into the file system and manipulating files, configuration files, touch files, or catalog files. This can cause some strange behavior in NetBackup and can lead to loss of a catalog. It can harm your NetBackup environment. So typically you want to change any of your settings within NetBackup or from the command line using NetBackup commands. Unless you're very familiar with what you're doing from outside of NetBackup, it's typically recommended that we don't go in there and manually manipulate files. Another thing to make sure we're always doing is performing catalog backups. Ideally, you want to perform these catalog backups after every round of backups. So if your backup window is from, say, midnight to 8 a.m., you want the last operation you do when your backups finish up to be your catalog backup. So you've done all this work, you've backed up all this data, you've entered all this catalog information. Now you want to protect that catalog because that is what the listing of what's been backed up. So you want to protect that. And ideally, that should be done by a catalog backup at the end of each round of backups. Some factors that will impact your performance, policy growth. By default, NetBackup is going to read through all of your policies to determine what's due to run. And it has to look at every policy, every schedule, and it has to figure out when the next run is going to happen. If you have an extremely large number of policies, that can cause master server to become bogged down and either not make it through in its 10-minute window to scan all the policies or take a long time and not getting your job scheduled and running as quickly as it should be. So you want to control your policy growth, combine your policies that have like retentions and like client types so that you're as efficient as possible. The more efficient you are here, the quicker your jobs are going to get into the queue and get processed, and the simpler it is going to be to manage. That's a key factor in performance. Another item that we see a lot of is when you have a media server that is no longer in your environment, whether it's being decommissioned or repurposed or is no longer going to be run in backups, it's really important to properly decommission that server. And when you're decommissioning a server, what you're doing is you're removing it from your NetBackup environment. So you're telling your master server, this server no longer handles backups, and it no longer has any images on it. And there are ways where you'll move the images off of there. If they're tapes, you're going to reassign your tapes. If there's images that are on there in disk-based storage, you'll want to duplicate those images to another location. But it's a key factor to take that out of your NetBackup environment and let your master server know that that server is no longer valid. Otherwise, your master server is going to continue to try to communicate with that server and may even, under certain circumstances, attempt to use it to perform backups. So you want to let NetBackup know it's no longer there. If a media server is no longer a valid server, whether it's crashed or whether it's being removed and hasn't been decommissioned properly, what will happen is if it's just one server, NetBackup will be bogged down periodically as it's querying that server, trying to reach out to that server and get a response from, hey, are you alive? What storage units do you have? Can you handle backups? What's your stream count? For one media server, that's not typically a deal breaker. But when you start to get 2 or 3 or 4 of those servers and it has to wait until it times out, not getting a response back, that's when you start to run into problems where NetBackup is every 5 minutes has to get the status of the disk pools, and it has to check and see what it's doing. And if we have 4 servers that are not responding and it has to wait for it, when it queries the first one, it has to wait for it to time out and then go, oh, okay, it's timed out. I'm going to move on to the next one. In the meantime, it also has to mark the disk down, and it's got to take certain actions on the master server as far as resources, making those resources not available. So this can cause NetBackup to exhibit some strange behavior. Job scheduling is lagged or slowed down. Jobs failing. Disk pools being reported down that aren't necessarily down. Those are the types of behavior that we've seen from that. So that's something to consider. And the last item for a master server is monitoring the catalog size. As a rule of thumb, if your catalog grows to be over 1 terabyte in size, this can cause NetBackup to struggle to manage that large of a catalog. There's a large number of files. There's the database components as well as the flat files that make up the catalog. And it can put a heavy load on a master server to manage that large of a catalog. If your catalog is 1 terabyte or a little larger, it may be time to consider splitting that NetBackup domain into 2 NetBackup domains. So you'll have 2 separate master servers to handle the load, and you'll split your clients between them. But it's a good practice to try and keep that 1 terabyte or less. So let's move on to the media server component. For your media server, some of the best practices. Again, we want to have a dedicated resource. The media server should be dedicated to NetBackup. You don't want to have third-party applications on there because those will tend to take up resources and you're going to impact your data movement. One of the things that you might find in a situation where you're using it under multiple roles, if it's a vCenter server and a media server, during your backup windows, you might find that your vCenter server is non-responsive, or it may be very slow to respond. And that can impact your VMware environment. If you're housing a database on there, you may find that your database is non-responsive or very slow to respond, and that can have a significant impact on your production environment. So it's typically a good practice to keep that media server separate. Always consider your resources, including RAM, CPU, network speed, and disk space when you're scheduling your jobs for your media. Since your media server handling the bulk of the work, it's actually ingesting data at a high rate of speed and writing it out to disk. That's a lot of work. And when you start to get around 40 to 50 streams of data coming in, you're going to max out something, whether it's the amount of RAM, whether it's a processor, network, or disk space. You'll want to monitor those and evaluate the media server's ability to provide resources as jobs increase in load, in either in additional numbers of jobs or additional data added to them. You're always going to have that bottleneck, and ideally you want to kind of be bumping up against that, and you want to be, typically you'll want that to be your network as your limiting factor. You want to make sure that your RAM and your CPU are not maxed out. One of the key parts to the RAM is if you're doing deduplication, specifically NetBackup, Media Server Deduplication, or MSDP, that requires an additional amount of RAM per terabyte of deduplicated storage and a lot of resources. You'll want to monitor that and make sure you're not bumping up against that limit. Another best practice, use separate fiber ports for your tape drives and disk storage, specifically in the case of VMware SAN-based backups. Ideally, you don't want to be backing up VMware virtual machines across SAN where your tape drives are, because you're going to be pulling that data in across the HBA and then back out across that same HBA, and what you're going to end up creating is a bottleneck. So ideally, you want to separate those 2 separate HBAs or 2 separate ports so that you're not trashing the link. So you want to keep an eye on that. Limit your storage server credentials. Within NetBackup, each disk pool has a list of credentials, and those credentials are which media servers can access the disk pool. The simplest way to do this is go ahead and add every server to have access to every disk pool. Well, what you end up getting is if you have 20 media servers with access to all the disk pools, and each one has disk pools, so you have 20 disk pools, each media server has to know the status of all 20 disk pools. What you'll end up having is a lot of chatter going across your network link as these servers are talking to each other, and you'll start to see error codes 2074 and various other status codes like 84 indicating the disk pool is either down, or in the case of an 84 you have a media write failure. This can be attributed to having too many of these credentials. Under ideal circumstances, what you'll want to do is control which servers have access to which disk pool. All the servers need to have access. And so you'll want to consider that when you're designing your implementation and controlling that. Another key factor is using robust network, fiber, hardware, using good quality switches. The weakest link is always going to be where you're going to run into problems. If you're using an 8-port unmanaged switch to handle your backup traffic, the chances are you're going to run into some problems with performance. An unmanaged switch isn't necessarily going to allow you to control the duplexing. Typically, our shared bandwidth across the backplane, so you'll find that a 1 gig switch really has about 5 gig of total bandwidth, even though it has 8 ports. There's some difference there as compared to a Cisco switch. So the better hardware you have, the better performance you should expect to see, as well as stability. So hardware is a key factor. NetBackup relies heavily on the network and the stability of the network. It's one of the best networking analyst tools you'll ever find. It will tell you if there's a network problem. Another consideration for a media server best practice, understanding multiplexing, multi-streaming on your tape drives. There are 2 components you can use. Multiplexing is allowing you to send multiple backup images to one tape drive at the same time. This can be beneficial if you're trying to move large amounts of data to a tape drive and you have several slower clients. If you have older clients, or maybe they're on a slower link and your tape drive isn't really pushed that hard. If you have the latest generation of tape drives, a 100 meg connection may not be sufficient, is more than likely not going to be sufficient to keep that tape drive constantly moving forward and writing data. So you can multiplex streams together. Maybe you take 3 or 4 of those clients and combine their images to one stream and send it out to the tape drive. You want to be aware of how much data you are sending to tape drive at any given time. If you send too many streams, if you were to send, say, 15 streams to a tape drive, and those streams all have sufficient bandwidth, what you'll end up doing is you're overwhelming the tape drive, and the performance will actually degrade significantly because you're having to deal with 15 streams of data being turned into one stream to the tape drive. This can cause performance issues. So you'll want to gradually increase that. Start with around 2, move your way up. The average is around 5 to 8. Any more than 8 can cause issues. Another common best practice that I see this one a lot is exceeding the high watermark on a disk. By default, data domain has a 90% high watermark, and MSDP has a 98% high watermark. And what this is the percentage of disk that is used at the time. So in the case of a data domain, when you reach your 90% high watermark, what's going to happen is it's going to send an alert to NetBackup to say, hey, I'm at 90%. I can't accept any more data. We need to clean up before I can continue. If you exceed that high watermark and move that up to, say, 98%, what's going to end up happening is you will use that 98% of the disk. But when the data domain goes to clean up, it's going to have a difficult time cleaning it up. And it needs at least 10% free space to be able to move data into that space as it's reorganizing it on the disks. And if it doesn't have that, it has to work with a much smaller footprint, which means it can't handle the data efficiently, and your performance will really poor on that data domain. In the case of MSDP, that threshold is 98%. Typically, I would not go beyond that 98% because that space is needed for cleanup and management of the resources. Best bet is to leave those at the defaults. Never manually remove a backup image from storage outside of NetBackup. Under normal circumstances, you wouldn't want to go in and on a basic disk where you've been running your backups, you can see all those backup IDs out there. They're essentially zip files that you're seeing out there. Removing one of those zip files outside of NetBackup, NetBackup is not aware that that's been removed. We'll still have the catalog information, and you can look at the resources that are contained in that backup, and you could even set up a restore job. What will happen is when it goes to perform the restore, you're going to get a media read fail, and you're not going to be able to restore the data, but NetBackup thinks it's all in there. The best practice here is to use NetBackup to expire the backup off of that disk pool and let NetBackup handle the cleanup process. Outside of NetBackup can cause issues and can cause inconsistency in catalogs, so it's important that those files are left alone. So let's move on to client component here. One of the key considerations with a client is that client is typically a production server or workstation. In other words, it has a role. It's either a database server or a file server or something along those lines. We want to avoid putting too many streams of backup data out of there at one time. We allow 10 streams of data to go out of there. What we're going to end up doing is saturating the network and using the processor and memory to the point that it's not able to handle its function, primary function, which is either serving database data or your file server data. And so this can impact your performance. So you want to take those into consideration when you're setting up your number of streams. Monitor your client processor and memory utilization and its response time across the network to make sure it's still able to handle its primary role. The next part of it is to set reasonable expectations for your backup speed. You'll want to look at the connectivity. Your client is connected to a 100 megabit link. We need to be aware that we're not going to expect to see gigabit performance. So those are factors that can play into your backup speed. Your client is across a WAN link, and that WAN link is a 1 gig link. We want to set reasonable expectations of what we can expect for performance. And there may be other things traversing that link, so you'll want to keep that in mind as you're setting up and anticipating what your speeds are and making sure you meet your window. Another thing to avoid would be to back up network streams through a client. And the reason for this is you have to move the data across your network link twice. If you have a NFS or CIFS share that you're backing up through a client, you have to move that from the NFS share to your client and then from your client to your media server. You want to avoid this as much as possible just to make sure that you are moving the data as efficiently as possible. And there are alternatives. One of the best practices I would recommend is using your media server as client in that scenario and avoid using another client so that your data moves across the network to your media server and then out to storage without having to traverse. Keeping your client software up to date. You'll always want to keep your client software at its highest possible version. Taking into consideration your master server version, your client version should be at the same or less version than your master server. You would also want to keep that at the latest version you can. You wouldn't want to be running, for example, a 7.1 client with a 7.6 master server if you can avoid it. If your server is supported to run a 7.6.1 client, you would ideally want to do that and take advantage of some of the features that go with that. Accelerator and things that will enhance performance and enhance the backup whether it's resources that you're getting or avoiding issues with versions. Some of the older versions handle things differently. As the newer versions have come out, they've become more efficient or they add more features in. So you'll want to kind of keep those clients all updated, the best practice to do. NetBackup relies heavily on your network. It is the core component of NetBackup. All your data at some point is going to cross a network, whether it's the metadata between the master server. There's always some network connectivity going. One of the key features of NetBackup is it's going to use DNS in several different ways. One of the things it uses DNS for is to keep your catalog consistent. Client name in your catalog is its DNS name. It makes it much simpler for your restores. It also is used as a form of authentication within NetBackup just to make sure that the client we're connecting to is the client that we want to back up data from. So DNS is critical. Take into consideration your subnets, VLANs, and duplex settings on your network to make sure everything is. If you enable jumbo frames on one server, you should enable them on the remaining servers on that network to keep everything consistent and allow for the best performance. So network is going to be a key factor, and having a solid, well-maintained network will lead to solid, well-maintained NetBackup that performs consistently. So let's dive into some of the deduplication technology. This is one of the things that is become very popular in the backup world just simply due to what deduplication does. Fantastic technology, has some interesting concepts and nuances, and we're going to dive into those. I thought I would start off with an overview to kind of lead into the discussion of data types and things that can impact your deduplication performance both in throughput and deduplication ratios. Starting off with the overview of the deduplication technology. So the core concept of deduplication is that we don't need to store the same segment of data multiple times and have a one-to-one ratio. So the simplest way to look at this is from a high-level view, all deduplication has the same basic principle. Data is sent to the deduplication engine, which breaks the data into segments. Those segments are assigned a unique value based on their data, and it's not the type of data so much as the signature of the data. There is different technologies use a little bit different method for this, but it's a unique value that's calculated based on the data. So after it's broken into these segments and they're assigned a unique value, as the data has got its unique value, it's compared to the existing data. So if a segment comes in with a signature of A, we look at this diagram here. So we have data coming in and it's broken up into these chunks. And for this example, we're going to use A, B, and C. So if our data file has this signature of A, B, C, basically all of these here, we break it into these chunks. Then what we're going to do is we're going to ask the database. We have a block of data that matches this signature. If the answer is yes, we say, okay, we don't need to store that. We just need to know that this block of data is associated with this file as well. So a single segment of data can be associated with multiple images and typically will. If the answer to that is no, what we're going to say is, okay, we don't have that block of data. So we're going to write the data to the data store under data segments, and then we're going to record the unique ID. And we're going to say that A references this block of data in the data store and belongs to this backup image. And then we'll move on to B. So as you can see, based on that, the more data that you have that is similar, your deduplication ratios are going to be higher. So one of the key things about this is not done at a file level. It's easy to explain at a file level when you consider having 5 files that are identical. Would you want to store all 5 of those files, or would you write the file once and then have pointers that say, if you're looking for this file, it's here. If you're looking for that file, it's there, but they're the same file. So store the file once, have a pointer for all 5 entries. That's similar to how deduplication works, except it's done at a block level. It's not done at a file level. It's actually going to break that file into segments and perform its calculations based on it. So now that we've taken a look at the deduplication, let's move on to some of the impact considerations for deduplication. So let's start off with options. Encryption. Data encryption has a significant impact on deduplication. The reason is that your data is encrypted. It's not intended to be read by someone who does not have the key, and it's not intended to just transmit it as readable data. Therefore, your deduplication engine will struggle, and in some cases will store it because it cannot interpret the data to see if it's unique or not. So the encryption will heavily impact your deduplication rates. So you may not be gaining significant space by using your encrypted backups. The next thing to look at is compression. When you back up data and you're compressing it, you're already doing a form of deduplication. So that's something you want to consider. Under ideal circumstances, you do not want to compress a backup that you are writing to deduplication storage. Let the deduplication engine handle it, which will be a much more efficient job. Good comparison is take a zip file and try to zip it again. You'll find that there's very little gain, and in some instances actually make the file a little bit. So let's move on to data types. So some data types that can have an impact. NDMP data. NDMP is kind of data from a net backup perspective in that it does not have a client-side engine to handle its data movement. It does not have a net backup client that you install on your file or to move. So the data is gathered, sent by the NDMP daemon, and that is typically handled by the filer itself and is a product of the filer manufacturer. Backup relies on the inbound stream peering in that stream and attempting to and it does not do a very good job of that. It's an issue of, since the NetBackup client software is not gathering the data, it's not able to effectively look inside the data to determine if it should be duped or not. It can't effectively do that. One of the workarounds for that is to back this data up to an advanced disk and duplicate it over to your deduplication technology, whether it's data domain or MSDP, and you'll find much higher rates. The next data type that can lead to lower deduplication rates are going to be databases, Exchange, Oracle, SQL, and other types of database engines that are supported by NetBackup. Deduplication rates can vary on this data. So typically recommend that you'll want to leverage your advanced disk here as well to see if you're going to determine if you can get better deduplication rates. A good test is to back up to advanced disk image over to your deduplication pool and look at the deduplication rates and compare them to straight backup to . Windows and non-Windows backups. So these are your server's operating system. These will usually deduplicate very well. If you're backing up 10 Windows servers, the core Windows OS contains generally the same files. And although we're not handling this at a file level, the data within the files is the same. So you're going to get a significantly higher deduplication rate. A good example in this is if you have 10 servers that are identical, you should see a 10-to-1 deduplication rate. Like operating systems will deduplicate well against each other. Items to consider. Database dumps. Database admins are fond of dumping their SQL databases or Oracle databases to disk first, and then having a NetBackup job scheduled to just back up that file system. That does present certain advantages for a database administrator, but the other side of that is that your deduplication rates can tend to be very low on this data because the data tends to be very large and it contains the entire database. And databases are already highly optimized. The ideal reason you would use a database is to have organized data, structured data, and store it as efficiently as possible. So a database dump contains all of that data and tends to have low deduplication rates. So some best practices for getting the best deduplication rates. Group your data types together in the same disk. So if you're running Exchange database backups, you'll want to consolidate all of your Exchange backups to go to the same deduplication pool. They'll work together. They'll deduplicate against each other very well. Evaluate your data deduplication rates by type and consider separating certain types of data from each other. For example, Oracle archive logs may not dedupe well with NDMP data that are using different disk pools. So with deduplication technology, and we're using those unique segments of data, NDMP and Oracle data are different structured types of data, and they will not deduplicate well against each other. So you would expect that the two of them on a disk pool may not yield high deduplication rates, as opposed to having all of your NDMP on one and all of your Oracle on another. Those usually will lead to higher deduplication rates. And some experimenting with that will help. And again, leveraging your advanced disk and then duplicating the image to deduplication pool can help to improve ratios. So now that we've gone into some of the impact of data types and covered some of the high level of application, let's move on to stream counts and networks. This is another critical component of achieving the best performance you can out of NetBackup. So stream count. When you have a media server, you're going to be limited by some factor, whether it's the network, RAM, processor, or disk storage, or disk performance, you're going to be limited by some factor. And ideally, you want to evaluate what type of data, how fast you need to move it, and where to put it, as well as how many streams of data you can send to a media server simultaneously. If you send 100 streams of data to a media server, you may overwhelm it depending upon the media server's capabilities. So when setting this value, it's a good idea to start smaller and increase your stream counts while monitoring all the performance data to determine at what point are you reaching a tipping point where your performance is going. A good example of this is having 100 streams that move at 100 meg each is going to be slower than 5 streams at 30 megabytes per second. So you want to consider the amount of data you're going to move should be your key deciding factor, not the number of streams. The number of streams, it tends to be a red herring if you are trying to achieve the maximum number of jobs active, it does not always equate, and usually does not equate to more data at a time. Focus on your data movement rate and finding the ideal stream count that achieves that. It really comes down to the number of concurrent tasks that your media server is going to be asked to perform. Network limitations. While in your planning stages, it's best to weigh the amount of data to be duplicated or replicated against your link speed. In the case of a WAN link where you're replicating to a remote site, consider what your link is and how much of that link you're able to use for moving data. Most companies will have a WAN link, and that link will serve as their connection between offices for email and other things, and we don't want to overwhelm that, so you want to weigh that in. If you have a smaller link and you're trying to move too much data, you're going to lead to a large backlog of either SLP or manual duplications, and the only way you're going to work around that is manual intervention. You'll have to prioritize your critical backups or duplications. So you'll want to take that into consideration when laying out your environment. Let's move on to the error overview. So NetBackup, one of the NetBackup features that is very popular, error feature, automatic image replication, where it's going to allow you to have an image stored in two separate NetBackup environment, separate NetBackup catalogs, and it will allow you to perform disaster recoveries much quicker. In the legacy way of doing this, you would have to restore your catalog at your DR site. That would allow you to perform the restores. With error, you don't need to do that. You back up the data at your source site, you replicate that data to your target site, and then your target master server will fast import that image. And it will take the catalog information and put it into its catalog. In the event of a disaster recovery, you simply issue the restore from the DR side. There are two SLPs involved, one on the source side, which contains the backup and the replication step, and then on the target side, you'll have an SLP with the first step as the import of the target side. So moving on to implementation of error and SLP duplications. Best method for implementing these is to phase them in slowly. Start off with a couple of SLPs, determine what's the impact on your network, determine what's the impact on your storage, and then gradually add in additional SLPs as your throughput allows, and monitor your backlog to see what is the average time it's taking. If it's taking 8 hours to get an image across, you may want to evaluate, is it a network limitation? Is that an acceptable window? How often do you want to allow this to happen? But phasing those in gradually allows you to determine at what point that you're going to start creating a backlog and determine what your recovery point objective is going to be. If you have implemented them all at once, what will end up happening is you'll build a backlog, and now you're caught in a situation where you have to find a way to get those critical ones over there. Which ones are you going to cancel? And this is going to involve a lot of overhead, a lot of manual intervention, and a lot of time to consider. So breaking into it slowly is a much more effective way. One key factor, if you get into a backlog situation, if you cancel an SLP, immediately at the point of canceling, all images are assigned their retentions. When a backup is run and it is under SLP's control, in other words, it's going to be duplicated, it's going to be replicated, the image retention is set to infinite. That means that the image will not expire. That infinite retention is set until the image completes all of its steps. Once it's completed all of its steps, it then applies the retentions that it's supposed to have. If you have an image that is a 1-week retention, and it's going to duplicate to a remote site for a 1-year retention, and your backlog is 2 weeks, and you look in there and you say, I need to get rid of this. If you cancel that image, more than 1 week has expired or has elapsed, and that backup was due to expire. When you cancel the image, that image will expire from your catalog and you will lose that backup. So that's an important consideration. So let's dive into the SLP best practices. Some of the information we provided here prior to this is going to help with this. Data direction. So when you're running a backup to a disk pool, ideally what you also want to tie in if you're going to use Open Windows is that you have inbound duplications or replications happening at the same time so that all the data is going to disk. You don't want to have 5 streams of data coming out of a disk and 5 streams of data going into the disk, although those numbers are real low as an example. But if you were to use, say, 50 streams writing and 50 streams reading, you're going to create disk thrashing and you're going to have I/O contention. So you'll want to weigh that out. And ideally, you want to try to move data in the same direction. SLP windows. Use SLP windows to control when SLP run versus backups. And this is a great tool for the situation where your backups run overnight and then during the day you want to replicate those images to a remote site and you have the bandwidth to do it. You may want to set up those SLP windows that during the day you're going to replicate those images, and then when your backup window starts, you close out your SLP window. It can also be used to control network saturation. If during the day is production hours, you don't want to be maxing out that WAN link if you have other data going across, such as Exchange or documents and stuff like that. So you can use the SLP windows to control that. Next thing I'd like to cover real quick is SLP steps. When you're creating multiple copies of a backup, the indentation is important in where the source copy is going to be for your duplication. So in the example we see here, we're going to run this backup, and then we're going to duplicate that backup image to a location. And then we have a second duplication that's going to occur. The indentation determines where the source copy is. So in this situation, we're going to back up, we're going to duplicate the image, so we have the second step, which is going to duplicate it. Our third step will be to duplicate from the second step. If this highlighted step, the bottom one, was indented to the left one, we would make our duplication from our original copy. So that's another key consideration you want to look at when setting up your SLP. So let's move into some do's and don'ts. Just a quick punch list of items to consider. Under do, catalog backups. We covered this a little bit earlier, and a lot of this is just kind of a condensed version of that. Catalog backups are critical to maintaining a consistent backup environment. Catalog backup fails, take corrective action and rerun it. You may not want to wait until the next catalog backup is due. When you run backups, you're storing that information about those backups in the image database. The catalog backup grabs that data. If you don't have it and you have a catalog loss, lost those backups and you'll have to manually phase 1 and phase 2 in. Catalog backup is critical. Second step, check your job statuses daily. If you're seeing failed jobs, address those failures, get the job back on track. Set up email alerts within Ops Center or within NetBackup so that you get alerted when you have a failed job and take corrective action. And this ties into the addressing job failures right away. We want to avoid that. We don't have that data backed up when we need a critical restore. So addressing those failures right away, taking the corrective action, get the backups when we avoid that whole situation. Another key step, do a Google search for NetBackup late breaking news, and you can input the version of NetBackup you are running. And typically you'll want to use the core version, 7.5, 7.1, 7.6, or those first 2 numbers of your version, and you'll find a tech article that will cover the late breaking news for that version. And that will list all the known defects, downloadable patches, new releases, known issues, and everything about the version. That can help give you an idea of what you may or may not run into, have instant access to fixes for things you do run into if a fix is posted, and you can subscribe to that article so that any changes to that article, you'll receive an email. So if a new defect is discovered, you'll have an email letting you know about it. So let's move into some do nots. We covered this a little earlier, raising the high watermark. This will lead to corruption when that cleanup process goes to happen. So it's ideal to leave that at its default. Manually manipulate the NetBackup catalog or the MSDP catalog. There are a lot of files that are managed by NetBackup that when you make a change in the GUI, they will reflect in a file somewhere on the system and really should not modify that. Some of those files are actually checksummed, and if you modify it, the file becomes corrupted and you can damage your NetBackup. So ideally, you don't want to modify those unless you're directed to by support. In the case of NetBackup appliances, not install third-party tools on the appliance unless directed by support. Installing third-party tools on the appliances can lead to some unexpected behavior. These are highly customized OS that are put on these appliances and may contain features or specialized code that could have some unintended effects on either NetBackup or the application you install in here. So best practice is not to install. Some final thoughts. Talked about this a little bit earlier as well. NetBackup relies heavily on your networking. It is the most robust network analysis tool you will find out there. If there is a network problem, you will run into something in NetBackup. It will find the issue. In case of NetBackup and packet loss on a network, lost packets will equate to a job failure. And the way I look at that is, if you had a zip file that you were transmitting across the network and chunks of that file were not there, the file is going to be damaged. You're not going to be able to open it. Effectively, that's what NetBackup is doing. When you're troubleshooting your NetBackup installation, there are some critical questions that you can ask that will help you determine rather quickly where your problem lies, and oftentimes will help you find the root cause and take corrective action. First question is, has it ever worked before? If it hasn't worked before, this is a new configuration, and there may be something within the configuration that you need to look at. If it has worked and has stopped, well, what has changed? Have the networks moved over to a new WAN link? Have they changed routing? Have you changed the host name of your server? Have you made some adjustments within NetBackup to timeout values? Those types of things can lead to failures. Are there any settings that have been changed from defaults? And this would be within NetBackup. If you change timeout values and now things are failing, maybe they're set too low. Are they below the defaults? Each of the NetBackup screens will have a default button, and you can look at those values. If you click the default, it's going to set those values to default. If you click the help, majority of those settings will show you the default value, what it should be. Ideally, click on help, look at the default values, and compare it to what you have. Is your DNS working? DNS is critical to NetBackup. If it's not functioning, you're not using host files, you will find backup failures. It's used for all job types, and it's even used as a basic form of security, as I discussed earlier. So DNS should be correct. Timeout values. If you have to change these timeout values from defaults, that's typically a good indication that there's something else going on. The default values are pretty well tuned within NetBackup. If you have to increase a Media Server Connect timeout to, say, 30 minutes, that may be an indicator that there's something going on with either that segment of the network or media server itself, or something that's hindering communication, and you should look at that. If you have to change the value, you should ideally try and find out what's going on that caused that value to have to change. Disk space usage. This is critical on a master server and can be important on a media server too, but more so on your master server. A disk full condition when on your master server will lead to catalog corruption and will lead to your EMM database stopping. So you'll always want to make sure that you have plenty of free space on your master server, specifically where NetBackup is installed. Make sure that you have at least, in a small environment, at least 1 gigabyte. That's a very minimal, but you'll always want to keep as much free space as possible on that server to allow for catalog growth and your database growth and your image growth. So that's critical to monitor on your master server. Always check the Veritas website for the latest best practice guides, manuals, patches, version information, and that goes along with subscribing to that tech note. That will give you the latest released information, latest patch levels for the version that you're on. And with that, I'd like to open it up to questions and answers. Have any questions that you'd like to have addressed? Daniel, if you
Are there any best or better practices with Oracle RMAN and deduplication pools?
There are guides out on the Veritas website that discuss how to set these up for best practices. Ideally, with deduplication in Oracle, you'll want to have them going to the same. You'll want your like data to go together, and avoid using a lot of the enhanced features like encrypting your data and things like that. There are guides available on the Veritas website. If you search the Veritas website for best practices Oracle, more than likely find that guide. That's the best way to find that information. And that information is updated periodically, so you may want to subscribe to that tech article that has the documents to get the latest changes to.
Okay, do you have any recommendations for maximum number of policies?
This will come down to the size and capability of your master server. If you have a very robust master server with a large amount of RAM, let's say it's 64 gigs, multiple processors with multiple cores, you can consider more, it can handle more policies. Depending upon the size of your environment, 30 to 50 policies is considered heavy. Having 50 policies can get cumbersome to a server. I've seen servers handling 150 policies, and you can see the latency in those. Even a heavy server with 150 policies tends to get bogged down a bit. So smaller is better. Ideally, you want to stay around that 50 or less mark if possible, but that's not always possible. Does that answer the question? That answers the question. If not, please do submit your follow-up to that, and we can answer that.
Okay, we've got another one. How does the accelerator option improve performance?
So accelerator is a combination of several features, and the core principle behind that is that it is going to determine what data needs to be moved from the client. Without accelerator, when you write data to a deduplication engine, what happens is the data is gathered from the client and sent to the media server. The media server sends it to the deduplication engine. At that point, it determines, do I have this segment? If I do, I discard that segment. I don't need it. It's already written to disk. I just reference it again. With accelerator, we shift some of that load over to the client. And what we're doing is the client will actually calculate the value for the segment and ask the deduplication engine, hey, I have a block of data with this segment information. Do you have that block of data? If the disk pool says, yeah, I already have that, then the client says, oh, I don't need to transmit that segment across the network. So you gain a large amount of performance because you're not sending over data that already exists. It's kind of like incremental backups, except that it's done at a segment level where we're not sending data we don't need.
Okay, great. There are a couple more questions, but we will follow up with those personally because we are running out of time. But I would like to thank everyone for attending today's webcast. An on-demand version will be available within 2 to 3 days, and you will receive an email notification once the recording is available. And again, for the questions that weren't able to be answered online, we will follow up personally with you. So thank you for attending.